way I worked them, and if you have a question, you can let me know. It didn't take us very long first period. I kind of felt like I went too fast, but they said they understood, so we'll see. First one, number one, wants to know about symmetry. That's the next to the last thing that we've covered was symmetry. So I tested the y-axis by replacing the x with a negative x. So when I did that, I had 5 times negative x equals 4y squared plus 3. In order for that to be symmetric to the y-axis, when I simplify that, that has to be the exact same as the original equation. 5 times negative x is negative 5x. There's no way around that. And negative 5x cannot be the same as positive 5x. So that is not symmetric to the y-axis. So I can mark out anything that's got y-axis, which means I can also mark out anything that's got origin. Because if it's on the origin, it's got to be both of them. Okay, that tells you the answer, but we'll go ahead and look at the x-axis anyway so you'll know how to get it. To check the x-axis, you switch the y to a negative y. And when you do that, you see that negative y is being squared. And when you square negative y, square a negative, it turns it back to a positive. So that ends up staying exactly the same, which is why it is symmetric to the x-axis. Okay, very good on number one. X-axis, good. Number two, pretty easy one. You can kind of go back to like when you were a little tot and play connect the dots there and see if that makes a linear graph or a quadratic graph. You do got to know what those mean. A linear would be a line, a quadratic would be a parabola. So on number two, when you connect those dots, it's going to look similar to a parabola. So you know it's either A or B, a quadratic. It opens up, which makes it positive. So it'll be a positive quadratic on number two. Okay, we good? Number three has to do with piecewise functions. I liked number three, but it was written different, so some people were confused about how it was written. You need to read that problem on your own there. To sum it up, the number of the month is going to be what the x is, and then when you plug that in, that tells you how many centimeters of snow they got that month. So the question asks, what is the deepest snow depth? So looking at the function they gave us, the first equation says 15x, F10 I guess could work, it says 15x, and then out to the side of that it says to use that function when x is from 0 to 3. So I know the biggest number I can plug in on that is 3, right? Because that's what it tells me out to the side. So if I plug a 3 in on that, 15 times 3 would get us 45 centimeters of snow. Okay, now let's go down to the second equation. 97 minus 14x. Okay, this one I can plug in numbers between 3 and 5. Look out to the side of that equation. You see it's got between 3 and 5 there. Probably, you could plug a 4 or 5, either one in. I plugged a 5 in on my paper. I did 97 minus 14 times 5, and that got me 27 centimeters of snow. Okay, I'm looking for the most snow, so far it's 45 centimeters, right? The third equation says 162 minus 27x, and it says to use that equation from 5 up to 6. So if you plug a 6 in there, 162 minus 27 times 6, this was the weird one. That's the month when there was no snow. I got a 0 on that one. So my highest amount of snow was that 45 centimeters. And we got several questions like number 4, or to ask about the maximum or the minimum or when it's the most. Those all have to do with vertex. So anytime you're asked about maximum, minimum, or what's the most, you're dealing with vertex on that. So it says the object is thrown upward with an initial velocity of 11 feet per second, and then a time feet is given by that equation. So that equation, to find the vertex out of that, starts off as negative b over 2a. We spent a lot of time with that early in the unit. So the b in that equation is 66. So I would have negative 66 over 2 times. The a is negative 11. So that ends up being 66 divided by 22, which gets an x of 3. Okay, now I got to plug that 3 back into the equation. It's actually a t in the equation on the paper. I got to plug that 3 back in there and solve to figure out how high the object went. So it's negative 11. Instead of t, I put a 3 squared plus 66, and instead of t, I put the 3. I just plugged the 3 back in where the t was. Okay, you can check it on your calculator. I actually did old school stack multiplication on my paper if you want to see a archaic math. I've got it on my paper. I ended up getting 99 feet for that. So whatever object it was went 99 feet. And that 3, that was the time. So I'm assuming this was seconds. Yeah, that it took it 3 seconds to get 99 feet in the air. I don't know. Does that seem fast? I guess I never measured a lot of objects shot in the air. I don't know.
I think that's
Slow. My little sister was in the rockets, but I chased the cows while she was shooting the rockets. So
You know, I chase.
what? Your chase? Oh, I don't know what. Huh? I just remember we had to go to my granny's and shoot them in the pasture so she wouldn't blow anything up. And so while she was doing that, she had my granny and cows in the pasture. So I chased the cows. That's why she's a rocket scientist and I'm not.
Sure does.
Cows are big.
Pretty much. She has a PhD in mechanical engineering with the emphasis in aerospace. So she teaches engineering at Baylor, but during the summer she gets contracted. She's been to work at Boeing and NASA and the U.S. Air Force for her engine work. So, yeah.
So what you're saying is your sister's very, very wealthy.
Yeah, but you wouldn't know it. She
Doesn't
doesn't
show it.
Right. She just lives normal.
And smart.
Yeah. She's the smartest person I know.
Is that why you have all this Baylor?
Yeah, yeah. We both were into sports when we were taught, so every time they put a new poster scheduled, she sends it to me. There you go. You just learned a lot of stuff.
Smart.
I really don't know it, but it's on my phone.
Oh.
All right, we good? Number 5. A lot of people in first period forgot what that little circle between the F and the G meant, and they tried to multiply them. No, no, no. Remember that means F of G. So when it says F of G, you take whatever the G function is, the inside one, the one on the right, and you substitute it in for the X on the one on the left. So I'm going to start writing the F function, the one on the left, and it says 10X, but I'm not going to write an X. Instead of writing an X, I'm going to write what the G function was. 4X plus 4. Now that's not the end of the story because there was more to F of X than just 10X. It said 10X minus 7. So this was G. I plugged it in for the X. Now you just got some middle school simplifying to do. That gets you a 40X and a 40. And then you got like terms there. 40X, what is that, 33? That's it. Alright, number 6, you could do a few different ways. What most people in first period said they did was they just graphed all those choices in their calculator and saw which one looked the same as the graph up there, and that works, and that's fine. Do that if you want to. Doesn't bother me at all. The way I did it a little bit different is if I just had just the parent function, the absolute value of x, I know that it would just be a v at the origin. If I can draw one on there. Okay, that's because there's nothing being added or subtracted or multiplied to it. It's just a v at the origin. Well, on my graph, I see that that v is scooted left 1 and up 1. So I need to take that v from the origin and scoot it left 1 and up 1. Back in Algebra 2, we talked about when we move graphs left and right, it gets the opposite sign. So that would mean m with the x would be an x plus 1. And then up and down gets stuck on the end and it gets the right sign. So up 1 gets a plus 1. So that would be D as in dandy on number 6. And like I said, if that you don't remember how we did that in Algebra 2 that way, just graph the choices and see which one gets you the right stuff. Does that make sense? All right, number 7 is like we've had on the bell ringer the last few days. It just wants you to subtract the functions. We all right? I got f of x, which is 8x minus 7, minus g of x, which is 4x plus 1. So you just have like terms to subtract. 8x minus 4x. Be careful here. Negative 7 minus 1. Yes, ma'am. Yes, ma'am. Alright, so this hot dog question blows my mind. When we get to the numbers, y'all can try to explain it to me. It says, John owns a hot dog stand. His profit in dollars is given by that equation where X is the number of hot dogs sold. What's the most he can earn? Most, that means max, so we're looking at Vertex, so that's how this dude's going to start. Vertex, we start by doing negative B over 2A. So his B is 14. Negative 14 over 2. His A is negative 1. So that's negative 14 by negative 2, which is 7. Okay? Read the problem again. That means he's going to make the most money when he sells 7 hot dogs. That, to start off with, bothers me. I would think if you had a hot dog stand and you were going to sell hot dogs, you'd try to sell more than 7, but what do I know? I'm not a hot dog salesperson. Now, how much is he going to make when he sells 7? This is where it gets craziness. Look at the answer choices already. I mean, selling 7 hot dogs and you got those answer choices. Wow. Plug a 7 into the equation.
I'm selling hot dogs for a living.
I mean, you ought to, according to this. Negative stays there because it's part of the equation. 7 squared plus 14 times 7 plus 55. I got $104. He's going to sell 7 hot dogs and make a profit of $104. Divide that. Tell me his profit per hot dog. What's 104 divided by 7? Come on, Caleb. So he's making almost profit clearing $15 a hot dog. So if he's clearing $15 a hot dog, there's no telling how much. Well, it wouldn't be a whole lot more, but he's probably selling them for $16 or $17. Who buys a hot dog for $17? What is wrong with this world, Mason? I mean,
Mason has $60 in his pocket for that. Hey,
you can buy a whole pack of hot dogs for 88 cents. A pack of weenies is 88 cents.
It didn't say it's normal.
I think anyone that eats a hot dog is already messed up.
I know what they're made out of, but I still like them. So.
I don't like
Only
it.
7 people are willing to, though.
Yeah, that's true. I mean, it's making $15, but he can only get 7 people to spend that on him. Whew, that question blows my mind. All right, number 9 is a tricky one. Out of all the questions on the test, this is the one that makes me slow down and be careful the most. We're talking about making VCRs. There's a blast from the past. Anybody still have a VCR?
Yeah.
My mom's DVD VCR combo. She still has
Yeah,
that.
that's what it is.
It's crazy. I think I threw a VCR away over the summer when I was cleaning the house. Alright, so we're making VCRs. N of T is equal to 9T. That says T is the number of hours that the factory's been in operation. And N will be the number of VCRs that they've made. Then you got another one, C of N, and that's a lowercase n on this one, is 239 plus 29n. And it says that one is the cost of producing in units. And it's important to know what each of those equations stands for. It tells you that in the problem. We'll go back and revisit that. But the T obviously has to do with time, and the lowercase n obviously has to do with the number of them that you're producing. Okay, it tells us to find C of N of T. So that means we're going to take this n function, and we're going to substitute it in to the C function. Okay, that part's easy. That gets us 239 plus 29 times 9t. And then you can look at the choices and figure out that 29 times 9 is probably 261, just by looking at the choices, right? Because they all got that. So except for A. 239 plus 261t. Okay, it wasn't hard to get that, but then like I said, B, C, and D all have that. So now you got to be able to interpret what that C of n up there means. Okay, C, go back to your C equation. It says that that is the cost in dollars. So I need one that's got cost in dollars. So I'm looking at B, C, and D. B's got cost. C's got cost. D's got cost. Can't mark anything out. Okay, N. It says N is the number of units produced. Hold on, I need to rewind on something.
Uh-oh.
Well, I said something that might confuse you a little bit. On that, N of T. Okay, we're good. Cost, all three of those talked about cost. But then the N of T, what does the T stand for? Look at your stuff up there. It says T is the, what's T? Number of hours. So we need to see if any of them talks about hours. B does. C does not. You see any time in C? Mark C out. D's got hours. So we're down to a 50-50 chance between B and D. Okay, now what's different about B and D is strictly the order that it lists the stuff in. B first says number of hours. D second says number of hours. So it's flip-flop the order. Okay? What did we plug in first? We plugged in this one in here. So that was so we plugged the number of hours in, right? So we dealt with number of hours first. So we need the one that's got, oh, stop. This is why I don't like this question. We did plug the number of hours into the total cost function. Okay, so if we read this down here left to right, our final answer, this would be our cost, right, that we got to pay no matter what, and then plus this times however many hours that they work, right? Isn't that what that would mean? 261 times however many hours they work. So we've got cost, then plus additional hours. So we're looking for the one that writes it that way. Which one, B or D, does cost first and then your hours? D. And I know I confused y'all as I was talking through that, because that kind of question makes me slow down and think.
I just skipped on. It's complicated.
It would have been nice if after you plugged it in and got the 261 deal, if you could have eliminated more. This one, they were mean to you. They kept 3 of the choices with that part of it right. I like to be able to get a better chance. All right, 10, vertex. We're good at finding vertex. There's several vertex ones. I've already said that. Negative B. My B is negative 80, so negative 80 over 2 times A. My A is 5, so that's 80 over 10, which is 8. So I know I got to be 8 comma something, so it's already got to be either B or D. Plug that 8 back into the equation. 5 times 8 squared minus 80 times 8 plus 326. And y'all can test me on the calculator. I ended up getting 6 on that. So the vertex was 8, 6. The directions for number 11 are down there on the bottom. Graph the function. And then you got to turn the page to see number 11. This one was a mean question. This will be second mean after that one that we just talked about that I struggled on. The reason this one's mean is because those choices, A, C, and D, there's something very different about B. I hope you notice what's very different about B. But A, C, and D, it's down to spacing. You've got to be able to look at that and tell that some of those are closer together than some of them. And it gets even meaner because the y-axis, it goes up to 20. So they're not counting by 1. So not only you got to figure out what's closer together, then you got to try to figure out what they're counting by to get that up there to 20. So it wasn't a very friendly question for you, but first line that we got there, 4x plus 2, and it wants us only to show the part that is less than negative 2. So if there's negative 1, there's negative 2. I'm only showing the part left of that line. 4x plus 2 would cross the y-axis at 2, and then it would rise 4 and run 1. But I want to be to the left of that dotted line, so I'm going to go down 4 and left 1 every time. So 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. It says does not have a line underneath it on that x less than -2, so it'll be an open circle, and it'll keep going like that. All of the choices have something similar to that. A and B, there's something bad about, but A and B, that's both closer to the x-axis. C and D, it's down lower. So, I mean, I'm counting by one, so you can't really go by what I got going on. All right, the second line says to show the part between -2 and 3. So there's 1, 2, 3. And it's got equal bars on both of them. So it's got to be a filled-in dot. That's why I said there's something wrong with B. B's got open dots on this next line. If it goes through the origin and has 1, 1, x just means 1x, so it would be a 1, 1 slope. It'd look like that, and it touches both boundaries, so they both got to be colored in. So you've got that line. So all you can do so far is eliminate B because it left the circles open. All right, the last one says show the part to the right of 3. 3x minus 1 would cross the y-axis at -1, and then it would rise 3, run 1. That didn't get me far enough. Rise 3, run 1. So it's going to end up being way up here, and then look like that. Okay, so we've got to figure out A, C, or D out of this. If you look at C, I argued with first period that last part of the line that we just drew up there in quadrant 1 off the top of my screen, that on C, that slope appears to be steeper than it is on A and B. Y'all agree on that? So can probably mark C out on that. Looks like it's rising more than 3, because if you jump, I mean, that's going to make it jump from probably about 12 to about 20. That looks like it's rising about maybe 8. Something along in there, guessing on that scale. So now we're down to A and D. A, what I noticed, one thing on A is this is closer together on A, and on D it's spread way far out. So on my graph there, that would be, let's see here, this was 1, so then 2, 3, that's about 3 units apart on my graph. So A or D, which one of those would be about 3 units apart? It would be A because of the spacing in the 20 graph that they got on there. I hate that. I mean, the x-axis they did normal. They counted by ones, and then the y-axis, it's not even a whole number what they counted by. If you count those ticks, 1, 2, 3, 4, 5, there's 5 ticks. How do you make a 20 out of that? I mean, they counted by some random number. It's not cool. They're 4 each. Would that work?
4.
Whew. Yeah, 4 4s. All right. Page 4, as we're talking about 4s. 12's an easy one, so finally we got something after we had to rack our brain on that one. Gives us a graph looks similar to that. That mark on that vertex is over to the left 1, so that's a -1. Ask us to determine the intervals where it increases or decreases. We know we read a graph left to right just like we read a book. So we're going to ride our bicycle on that graph left to right. We would jump on the graph over here and immediately we're going downhill. So we're decreasing, and that's forever to the left. So negative infinity. When do we hit the bottom of that hill? -1, and it hits it so it gets a bracket. Okay, that tells you enough to know the answer. But then once I get to the bottom of that hill, I got to put on my pedaling, whatever you put on, and get to pedaling hard because it's going uphill from -1 to infinity. So that should get you a good A on that. All right, 13. 13, it tells you to decide whether the graph opens up, down, left, or right, but then all the choices, they just give you up, down. So they left you off the hook. You don't got to worry about left or right. You know it's going to be up or down. My A on number 13 is 1/7, and it's a positive 1/7. A positive A means it opens up. So we already know that it opens up on that. Now, when our A is less than 1, your graph gets wider. When your A is greater than 1, your graph becomes more narrow. So 1/7, would that be less than 1 or greater than 1? Less than 1, so we would have a wide graph opening up. That's tricky because you think a fraction's smaller, it ought to get narrow, but that's opposite stuff on that. Fourteen's a pretty easy one, but the wording could confuse you, so let's make sure we understand what they're talking about on the wording on it. Says f of -24 is equal to -30. That's like an input-output kind of deal. That means we plug a -24 in for the x, and we get a -30 out for the y. So if we're thinking about this on a graph, it would go left real far and down real far. There would be our -24, -30. Now the question says that's going to be symmetric to the y-axis. So your y-axis is this one. So that means we want to flip it and put it over on the same spot on the other side of that. So to get to that, we would come +24 and still our -30. So it would be the point 24, -30. So to write that as an input-output like the question did, you would say f of 24 is equal to -30. $15 is a friendlier graph one. It's not as difficult as the last one. I don't like it that they got the question on one side and the choices on the other, but we'll just have to deal with it. Everybody ready? Is that what you need there on 14? Alright, so 15, the first piece says the absolute value of x minus 2 and show only the part that's less than 0. So I'm going to go ahead and plug a 0 in. I'll just leave that as an open circle. It won't get colored in. 14, my bad, was C. Alright, so we plug that 0 in. Absolute value of 0 is 0, and 0 minus 2 is -2. I want to show, what did it say, less than 0, so I'm going to do a -1. Absolute value of -1 is 1, and 1 minus 2 is -1. -2, absolute value of -2 is 2, and 2 minus 2 is 0. So that would be 0, -2. And that one just gets an open circle because it's not, it doesn't say equal to in the problem. And then -1, -1, -2, 0. So you have something going like that. Now technically I told you an absolute value graph makes a V. That doesn't look like a V. Why doesn't it look, where's the rest of the graph? Why does it not look like a V? Right. It told me to only show the part that's left of 0. The V would be coming over here, right? But that's not less than 0. So I had to follow that rule and only show that side. That's a piecewise that we did the other day. Alright, the other graph that it gives you is just a horizontal line. F of x, is -2. So remember f of x is the same as y, so you go down to 2. And it tells me to show the part greater than or equal to 0. So normally that would be -2, right? But greater than or equal to 0 would start there and be like that. So you would leave this part off. So I'm going to flip the page now and look for something that gives me a connected obtuse angle. And it will be C. And then you get to turn another page. This test maker wasted some pages. Alright, we're going to look at 16 as soon as you get ready, Freddie. Still thinking about 7 hot dogs for $104. I mean, that's more than at a ball game. You go to the MLB game and they're like $7 a hot dog. They're even more than that. Alright, 16, we got to graph the parabola. First thing I did was marked out C. Okay, the A on number 16 is a +1, so that means it's got to open up. So I can mark out C. So I start finding the vertex, -b, so it's -2 over 2 times 1. So my x is going to be -1. So I'm looking for a parabola that's axis of symmetry is there. A doesn't have it, mark A out. B and D both got it. So now I got to plug that -1 back in to see if it's supposed to be above the x-axis or below it. So to get me -1 squared plus 2 times -1 minus 5. I did all that and got -6. So the vertex would be at -1, -6, which means it would be down here. Which means it has to be, which one? B as in boomerang. Alright, 17, you could get a couple different ways. You could just use common sense, but then I had some people in first period try to over-argue the common sense. The question says, a boy standing on a flat field and tosses the ball towards a second boy at the other end of the field. Path of the ball is parabola. There's your equation. Based on that, how many x-intercepts? Shh, y'all listen. Some people in first period wanted to argue that it won't have any x-intercepts because the ball's not going to hit the ground because both the boys are going to catch it. And maybe so, but where the ball starts at the boy, it'll finish at the boy. So the boy in this case will be your x-intercept. So one boy's got the ball, there's one x-intercept. Throws it to the other boy, he's got the ball, there's your 2 x-intercepts. Okay, way to do it algebraically is using the discriminant, which is just the part underneath the radical, b squared minus 4ac. So my b is 8, so 8 squared minus 4. My a is -4. There is no c, so it's 0. This whole piece will cancel out because you're multiplying it by 0, so you just have a 64 left. And we made a note that when our discriminant is greater than 0, which 64 is, there are 2 real solutions. So there's your 2 points of intersection. Page 7. I don't know. Yes. Alright. You're good? 18. Tell whether it opens up or down, wide or narrow. Okay? So we've got a 2x squared. So our a is 2. Our a is 2. 2 is bigger than 1. What did we say when our a was bigger than 1? Got narrow. Good. And since it's a positive, it opens up. So what choice are we looking at? B. Alright, 19. We're at the parabola. I marked out B because my A is a positive, so it should open up, so I didn't even mess with B. Okay, then if I started finding the vertex, x equals -b. There's nothing in the B spot, so my B is a 0. Divided by 10 is just 0. So its axis of symmetry has to be on the axis there. Okay, A's got it, C does not. C is scooted over to the right. D's got it. So it's either A or D. I got to plug that 0 back into the equation now and see if it's above or below. So 5 times 0 squared plus 4. 0 plus 4 is 4. So my vertex is at 0, 4. So what choice does that have to be? Last page, last question. This is the first sideways one we've had. You can mark B or D out. Why do you know that? What's different about the way the equation is written?
X equals.
Very good, Kelly. It says x equals. Okay? So normally we find the vertex by doing x equals -b over 2a. This one's the opposite. This one will be y equals -b over 2a. So my b is 3, so I got -3 over 2 times -2. So my y is 3/4. So that means if there's 1, I'm going up almost a 1. So my axis of symmetry will be up there. That tells you the answer. Yep, it has to be C. Thanks for that beep. Alright, we went quick, but is there anything that you need me to tell you that I went too fast on or that you didn't get? Have that on your test. Have that to use if you want to use it tomorrow. That's all I got. If you don't got a question.